Let's draw the Lewis dot diagram of NF3, also recognized as nitrogen trifluoride. We'll follow these simple steps to accurately draw the Lewis structure of NF3. First, we'll create a rough diagram of the structure. Next, we'll illustrate the chemical bonds between each atom. Then, we'll identify and mark the lone pairs on the atoms. After that, we'll ensure the octet is complete for each atom. Finally, we'll calculate the formal charges for each atom and determine whether the final structure is stable. To draw a rough diagram of NF3, first calculate the total number of valence electrons, then determine the central atom. The total number of valence electrons in NF3 can be determined by summing the valence electrons of each individual atom in the molecule. Nitrogen, a group 15 element, has 5 valence electrons, while fluorine, a group 17 element, has 7 valence electrons. In NF3, there is 1 nitrogen atom and 3 fluorine atoms. Therefore, the total number of valence electrons is calculated as 5 plus 7 multiplied by 3, which simplifies to 5 plus 21, which equals 26. Thus, NF3 has a total of 26 valence electrons. The central atom is typically the one with the lower electronegativity value. In the NF3 Lewis structure, nitrogen and fluorine are present, with electronegativity values of 3.04 and 3.98, respectively. Since nitrogen has the lower electronegativity, it is chosen as the central atom for NF3. Therefore, place the nitrogen atom at the center with 3 fluorine atoms arranged around it, and draw a simple rough sketch. 2 electrons represent a single chemical bond. We will place 2 electrons between nitrogen and each fluorine atom to represent 3 chemical bonds. In this way, we have used 6 electrons to form these bonds. Out of the total 26 electrons, we are left with 20 unutilized electrons. Lone pairs consist of electron pairs that are not involved in chemical bonding. Each lone pair contains 2 electrons. As mentioned earlier, there are a total of 20 unutilized electrons. From these, we can form 10 lone pairs and mark them on the structure accordingly. It's important to note that both nitrogen and fluorine are period 2 elements, meaning they cannot hold more than 8 electrons in their valence shells. Another important point to remember is to always begin marking lone pairs on the outer atoms first, before proceeding to the central atom. In the NF3 Lewis structure, each of the 3 outer fluorine atoms is assigned 3 lone pairs. The central nitrogen atom receives the remaining 1 lone pair, completing the total of 10 lone pairs to be distributed in the structure. The current structure clearly shows that each outer fluorine atom, as well as the central nitrogen atom, forms a complete octet. Therefore, the octet rule is satisfied for all atoms. Now let's check the stability of the structure by calculating the formal charges for each atom. This is the formula we can use to calculate formal charges for the NF3 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the data and place the values to derive the formal charges for each individual atom. For nitrogen atom, valence electrons equals 5, non-bonding electrons equals 2, and bonding electrons equals 6. So, the formal charge will be equals 5 minus 2 minus half multiplied by 6, which equals 0. For each fluorine atom, valence electrons equals 7, non-bonding electrons equals 6, and bonding electrons equals 2. So, the formal charge will be equals 7 minus 6 minus half multiplied by 2, which equals also 0. The formal charges on the nitrogen and each fluorine atom are indicated, and it is evident that the current structure is stable, as no formal charges are present on any of the atoms. Therefore, this structure can be considered the stable Lewis structure of NF3. To represent a bonding pair, we draw a single line between the atoms. In this structure, there is one pair of electrons between nitrogen and each fluorine atom, so we draw one line between them. This means that in the final Lewis structure of NF3, the central nitrogen atom forms single bonds with the 3 outer fluorine atoms. This concludes our discussion on the NF3 Lewis structure. If it helped you, be sure to like the video, share it with your friends, and click the subscribe button.